Hello, my name is Krishna. I'm a product manager here at Anritsu. Today I'm going to show how one can measure electrical length and loss profile of a coax cable using a ShockLine VNA. For this demo, I'm using a ShockLine MS46524 VNA and a semi-rigid cable from Anritsu, which I will refer to as a DUT cable. Setup wise, I'm using a frequency range from 50 kHz to 43.5 GHz with IF bandwidth of 1 kHz, and the number of points is 1000. It's important to have a decent number of points to avoid any aliasing issues. If you already have a two-port, if you have already done a full two-port cal, you can use that setup and just insert our DUT cable and get the measurements with just few clicks of a button. If you do not have a full two-port cal, there is a quicker way to get these measurements just by doing a TFR cal, which is a transmission frequency response calibration, which is just a through cal. Procedure is very simple. Before measuring the DUT, we will need another cable, another coax cable, which I will refer to as a cal cable. We'll do the TFR cal using this cal cable. Once cal is done, I will insert the DUT cable and measure the parameters. Let's go through the measurements now. I've connected the cal cable. To perform the TFR cal, we'll go to calibration, calibrate, manual cal, transmission frequency response, through 1 2. Click OK and done. So this is our S21 response. We are using the ports 1 and 2. Now I'll connect our DUT cable in the setup. I've connected the DUT cable. Now to measure the electrical length and loss parameters, we'll go to measurement, reference plane, click on auto loss and length. This gives the distance. What we see here, 78.55 centimeters, is the electrical length of the cable, and the loss profile, it's at reference frequency of 50 kilohertz. It has 0.002 dB loss. The loss for a coax cable follows the square root of frequency rule, just to give an idea. So loss at frequency f is a reference loss times square root of f over frf. Here frf is 50 kilohertz and loss at frf is 0.002 dB. If you want to know the loss at a particular frequency, say 40 gigahertz, if we plug in into this equation, we will get that loss. In other way, you can also see if we change this reference frequency here to 40 gigahertz, and the loss we see in the marker is measuring around 1.7 dB. If you use that equation and plug in those numbers, it should come equal to the same 1.7 dB. That's all I have for this video. Hope this video was informational. Thank you for watching.